Okay, so we'll be talking about quantum. I think that has been our topic since forever. And we will be talking about uh, decoherence. Sorry, wrong color. Decoherence. Okay, and coherence as well. So these two topics are one of the most important fields of topics in quantum mechanics, as they they play a major role in our our development of quantum computers. Okay, so what we are talking about is, let's imagine if we have a quantum system in which a particle p1 is in a superposition state, and that state, of course we know that particle will be existing in multiple states, which we say as alpha or any constant of states, all the states possible. I'm just writing in simplicity, or it's to be accurate, let me write like this: plus b and so on equals to psi this. So this is what the particle, which this is the state, superposition state. Okay, so what happens is decoherence. Decoherence is nothing but is the interference or interaction of the environment with the quantum system. Okay, now what I mean to say is, in it, the term environment, anything can come in it. Either it's a, um, a sound wave, heat energy, and etc. Okay, even a clap sound of clap. That's most weird, but yeah, any interference of the environment can play effect. And the reason of heat energy, the 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 reason that it cause there's a movement or there's a decoherence on heat energy, that's why the quantum computers, they are kept at low temperatures, and by low I mean a lot, which is near absolute zero. Okay, So decoherence can also be explained in such a one more way. Let's suppose we talk about Q QKE, quantum key distribution. Okay, so in quantum key distribution, in quantum key distribution, what actually happens is there are two people and their task is to send message to each other, and they use quantum key distribution. Okay, so if this person sends a message to this person, and then what he does is he decodes the message sends the message through quantum signals. Okay, receives and sends decodes the message through quantum signals. Okay, so sorry, so what actually is, then after that then after that the sender sends a basic basis information. Mean what base is it in? Okay, because it could be either like this, or it could be this as well. It could be up, down, or there are more as well. This is what the base is actually. So, but let's suppose if we have a third person in this information sending, and he also looks at the message, and then the message goes, of course it goes to other person as well. So what will happen is the third person is the decoherence here. How he interfered with the message? He looked at the message. Then also one more thing, the receiver will know that there was an interaction before, because what happens is that, let's suppose if he sends uh, a state which is in horizontal, okay, and then he sends it to the receiver, and the receiver uses the information information of basis and gets his answer. Okay, gets his answer, or what the message is actually. But if we have a third person, he will receive he will he will not get the right answer or right message. Okay, so decoherence is the disturbance which is made in such a way that the system or the quantum system or the atoms particles are disturbed, and they they stop they stop particles. Okay, now coherence on the other hand is opposite of decoherence in such that the information coherence happens to be, we want coherence. Okay, okay, so coherence is, or we, it should be like, we want the coherence not to be disturbed, not to be disturbed. Okay, so when the system starts, the coherence is there. Okay, if everything works out, then coherence is fine. I mean, it's working. There's no decoherence, and we get the desired sorry desired answer. When when we when we want when we want the answer to be more accurate, then the process, what happened actually process is repeated. Meaning, I suppose if this is our if this is just a state, let's suppose, imagine, and this is a starting state, and this is a state we want. So when we do the experiment or the process, what we find is it's getting closer. The more the gap, the more the gap The more the gap between these two, the the more high probability. Okay, but how it works is, first this over here, this state over here is put into a superposition state, and then it's taken an inverse of -1, and it comes in the negative quadrant, and from here we take we when we take it again back to the first quadrant, the the gap is increased by applying. How we get it to a superposition state is, it's a qubit, by the way, by using a Hadamard gate, which is 1 by square root of 2, 1 by square root of 2, 1 1 1 minus 1. This is what Hadamard gate is. Okay, a qubit sorry, a qubit in superposition using Hadamard gate. Look over here, probability is high of us getting 0, our answer being 0, accuracy is increasing. Okay, and yeah, that's it. Thank you.